Look up at the night sky on a clear evening, and what do you see? A vast, silent expanse of darkness, dotted with distant stars, seemingly empty, almost peaceful. But what if I told you that emptiness is an illusion, that the void above us is teeming with secrets, hiding light so strange, so unexpected, that it defies everything we thought we knew about the universe? For centuries, astronomers gazed at those same dark patches, assuming they were nothing more than empty space, until one day, the truth cracked open. Those blank voids weren't empty at all. They were cosmic shadows, concealing wonders beyond imagination. This is the paradox of the sky: darkness that isn't dark, emptiness that isn't empty. Take the Great Rift in the Milky Way, for example, a sprawling lane of blackness cutting through our galaxy's glow. To the naked eye, it's just a gap. But through the lens of modern science, it's a cosmic sleight of hand, a curtain of dust and gas blocking the starlight behind it. And that's just the beginning. What if the universe isn't just hiding stars? What if it's concealing something far more unsettling, light we weren't meant to see? Light that bends the rules of physics, challenges our understanding of reality, and maybe even rewrites the story of existence itself. That's the journey we're about to take, from historical observers who brushed off these dark patches as nothing, to the groundbreaking discoveries that revealed their terrifying truth. We're diving into one of space's greatest deceptions. We'll explore how the cosmos plays tricks on us, how light can be both a messenger and a liar, and why some corners of the universe seem determined to stay in the shadows. By the end, you won't look at the night sky the same way again, because once you learn about the light we weren't meant to see, you'll realize the universe isn't just mysterious. It's hiding something from us, and the question is why. For centuries, the night sky fooled us. Early astronomers, armed with nothing but their eyes and simple telescopes, mapped what they believed to be the full extent of the cosmos: bright stars, wandering planets, and the occasional comet. But the darkness between those points of light, they dismissed it as mere emptiness, a void where nothing existed. Even the great William Herschel, who meticulously charted the heavens in the 1700s, described vast regions of the Milky Way as holes in the sky, assuming they were barren stretches of nothingness. It wasn't laziness or ignorance, it was a limitation of human perception. Our eyes evolved to see only a sliver of the light spectrum, blind to the faint glow of distant nebulae or the whispers of infrared radiation. The tools of the time were crude, like trying to study the ocean's depths with a bucket. Then came the revolution. Telescopes grew more powerful, cameras replaced sketchbooks, and suddenly, those empty patches of sky came alive. The Great Nebula in Orion, once invisible to many early observers, blazed into view, a stellar nursery hidden in plain sight. The coal sack that in Chi Blot near the Southern Cross wasn't a void at all, but a dense cloud of dust, blocking the light of millions of stars behind it. And Herschel's holes, they were cosmic illusions, curtains of gas and dust masking entire galaxies. The universe wasn't empty. It was playing a game of hide and seek, revealing itself only when we learned how to look. Yet even now, with orbiting observatories peering into infrared and X-ray wavelengths, we've barely scratched the surface. Dark matter, an invisible scaffold shaping galaxies, leaves no trace in the light spectrum at all. Some of the universe's most dramatic events colliding black holes, the birth cries of stars, are silent to our traditional instruments. The lesson is clear. Every time we develop a new way to see, the cosmos unveils another layer of its secrets. So what else is out there, lurking just beyond the edge of our perception? If history is any guide, the greatest discoveries aren't the things we've found. They're the truths we haven't even thought to look for yet. The human eye is a marvel, but it's also hopelessly limited. We see only a tiny sliver of the light that floods the universe, a narrow band of colors we call the visible spectrum. Step beyond that, and the cosmos transforms. Imagine tuning a radio dial through static, only to stumble upon the rhythmic pulses of a dying star. That's exactly how astronomers discovered pulsars, not with telescopes, but with radio antennas picking up signals our eyes could never perceive. These spinning neutron stars, blasting beams of radiation like cosmic lighthouses, were invisible until we learned to listen to the universe's hidden soundtrack. Then there's infrared light, the secret language of heat. Point an infrared telescope at what looks like empty space, and suddenly, clouds of cold dust glow with the warmth of newborn stars. The pillars of creation in the Eagle Nebula, those iconic towers of gas, are just the tip of the iceberg. Behind them, shrouded in dust, hundreds of stars flicker to life, unseen, invisible light. Even black holes, the ultimate cosmic voids, betray their presence through X-rays, superheated gas screaming as it's torn apart, detectable only when we look beyond what our eyes can grasp. But perhaps the most humbling discovery came from a different kind of invisible light, the cosmic microwave background. In the 1960s, two radio astronomers stumbled upon a faint, uniform hiss coming from every direction in the sky. At first, they thought it was interference, maybe pigeon droppings on their antenna. But that static was the afterglow of the Big Bang itself, a whisper of radiation from the universe's infancy, stretched over billions of years into microwaves. Suddenly, the empty space between galaxies wasn't empty at all. It was vibrating with the echoes of creation, a relic of when the entire cosmos was smaller than a single atom. So here's the unsettling truth. We're surrounded by light we can't see, signals carrying stories we're only beginning to decode. The universe isn't just hiding objects, it's hiding entire dimensions of reality. Every time we invent a new way to observe, from radio dishes to gamma-ray detectors, we peel back another layer of the cosmic onion. What else is out there, flickering just beyond the edge of our perception? Dark energy, parallel universes. The answer might not lie in the stars we see, but in the light we're still blind to. And that raises a haunting possibility. What if the greatest mysteries aren't in the darkness, but in the light we're not yet equipped to find? There's a strange idea in physics that the universe might be keeping secrets from us, not just by accident, but by design. It's called cosmic censorship, and it suggests that nature has built-in rules to hide certain truths, like a cosmic magician never revealing the trick. Picture a black hole singularity, a point where gravity becomes infinite, space and time break down, and the laws of physics as we know them simply stop working. According to Nobel laureate Roger Penrose, singularities don't just exist. They're deliberately hidden behind event horizons, the ultimate one-way doors. The universe, it seems, doesn't want us to see what happens in there. But why? Why would reality censor itself? One answer lies in predictability. In the visible universe, cause and effect are orderly. Drop a ball and it falls. But inside a singularity, that logic shatters. Time might loop, effects could precede causes, and the very fabric of existence could twist into knots. If singularities weren't hidden, their chaos might leak out, making the cosmos unpredictable. Think of it like a firewall, shielding the sensible universe from the incomprehensible. This isn't just about black holes, though. Quantum mechanics shows us that observation changes reality. Measure a particle's position, and its velocity becomes uncertain. It's as if the act of looking forces the universe to pick a side, hiding the full picture. Now apply that to the night sky, those dark patches we once thought were empty. What if they're not just veils of dust, but something far stranger, places where the universe actively censors itself, regions where light isn't merely blocked but forbidden? Here's where it gets unsettling. If the cosmos is hiding things, what gives us the right to uncover them? Every time we push the boundaries of observation, building telescopes that see in X-rays or gravity waves, we're peeling back layers the universe might have meant to keep closed. Are we solving puzzles or trespassing? The ethical question lingers. Some truths might be hidden not because they're impossible to find, but because finding them changes everything. And once you see what wasn't meant to be seen, there's no going back. Long before telescopes or satellites, ancient cultures gazed at those same dark patches in the sky, and they saw more than just emptiness. They wove stories passed down through generations that hinted at a startling truth. Humanity has always sensed there was something hidden in the void. Take the Aboriginal peoples of Australia, who looked at the dark lanes of the Milky Way and saw the emu in the sky, a celestial creature formed not by stars but by the absence of them. To them, these weren't gaps, they were part of a living story, a cosmic emu whose shifting position marked the seasons. Halfway across the world, Norse myth spoke of Ginnungagap, a yawning void that existed before time itself, a place of potential where fire and ice clashed to birth the cosmos. These weren't just imaginative tales, they were early attempts to explain the unexplainable, to give meaning to the darkness that seemed to resist understanding. The ancient Greeks had their own version, Erebus, the personification of primordial shadow, a realm so deep not even light could escape it. Sound familiar? It's almost as if these cultures, separated by continents and centuries, were picking up on the same cosmic whispers. Without the tools of modern science, they relied on intuition, on the nagging sense that the sky's emptiness was anything but. Now fast forward to today, we know those dark patches are often molecular clouds, dense enough to block starlight, or the imprint of structures like the Great Rift. But here's the eerie part. What if these myths weren't just poetic guesses? What if they were glimpses of a deeper pattern? Aboriginal elders spoke of the emu as a creator spirit, its body a map of sacred knowledge. Norse sagas described Ginnungagap as a chaotic forge where reality itself was shaped. In both cases, darkness wasn't passive, it was generative, a hidden engine of creation. That's where modern astrophysics starts to echo the ancients. Dark matter, invisible yet shaping galaxies, black holes swallowing light yet birthing quasars. Even the cosmic microwave background, that faint glow from the dawn of time, is a kind of echo from the universe's own Ginnungagap moment. The parallels are uncanny. Maybe these myths weren't just stories. Maybe they were humanity's first inkling that the cosmos thrives on secrets, that the most important truths often lurk just beyond sight. So here's the question, were the ancients onto something we're only now beginning to quantify? Or is it simply that the human mind, when faced with the unknown, tends to weave similar tales? Either way, the overlap between myth and science is too striking to ignore. It suggests that for all our technology, we're still chasing the same mysteries that haunted our ancestors. The sky hasn't changed, only our tools and perhaps our willingness to admit how much we still don't know. Imagine a universe where every civilization lives in terror, where the first rule of survival is silence. This is the chilling premise of the dark forest hypothesis, a theory that paints the cosmos not as a vibrant community of alien societies, but as a deadly game of hide and seek. Inspired by Liu Cixin's science fiction masterpiece The Three-Body Problem, the idea goes like this. In a galaxy teeming with life, the most rational choice for any advanced civilization is to stay hidden. Because in a dark forest, you never know if the hunter is lurking behind the next tree. Broadcast your location, and you might attract something far worse than curiosity. This isn't just fiction. Real-world scientists wrestling with the Fermi Paradox, the baffling absence of detectable alien civilizations, have seriously entertained the idea. Why, after decades of listening for radio signals, has SETI found nothing but cosmic static? One unsettling answer: everyone else is too smart to answer. Think of it like this: if predators exist in the universe, civilizations that announce themselves might not last long. The Great Silence isn't proof we're alone. It's proof we're surrounded by beings who have learned the hard way. Visibility is vulnerability. Now tie that back to the light we can't see. What if those dark patches in the sky aren't just cosmic accidents, but deliberate blind spots? Advanced civilizations might not just avoid radio transmissions. They could be actively cloaking their stars, dismantling megastructures to blend into the background, or even bending light itself to stay off the radar. The ultimate cosmic stealth mode. Even our own experiments with Dyson spheres, hypothetical structures that harvest a star's energy, could one day make our sun flicker unnaturally. Would that mark us as prey? The implications are staggering. If the dark forest hypothesis holds, the universe isn't just hiding light, it's censoring it. Not because of dust or distance, but because survival depends on staying invisible. Every silent galaxy, every unanswered signal becomes a warning, and that raises a spine-tingling question. Are we the naive newcomers shouting into the dark, unaware of the rules? Or worse, have we already been noticed? The sky's emptiness might not be a mystery to solve, but a lesson to learn. And by the time we do, it could already be too late. NASA declassified files read like a sci-fi thriller, pages filled with accounts of lights that shouldn't exist, voids that defy explanation, and corners of the cosmos that behave as if the laws of physics are mere suggestions. Take the case of dark flow, a discovery that sent shockwaves through the astronomy community in 2007. Researchers tracking the motion of galaxy clusters found something impossible. Hundreds of them were hurtling in the same direction at breakneck speeds, as if pulled by an unseen force. Not just any force, one so colossal it lay beyond the observable universe. The implications were staggering. Either our models of cosmic structure were catastrophically incomplete, or something massive, something we couldn't see, was yanking entire swaths of the universe toward it. Then there are the anomalies closer to home. Pilots and astronauts have reported eerie lights in Earth's upper atmosphere, flashes with no clear source, or sudden patches of darkness that swallow stars mid-flight. In 1992, the crew of the Space Shuttle Endeavour witnessed a bizarre, black stripe stretching across the horizon, a phenomenon with no scientific explanation at the time. Even Hubble's deep field images, those iconic windows into the distant universe, occasionally capture unexplained glows or regions where light seems to bend in ways Einstein's equations can't fully account for. These aren't camera glitches or optical illusions. They're cosmic breadcrumbs hinting at forces or structures we've yet to name. So what's really going on? One theory suggests these phenomena could be shadows cast by higher dimensional objects. Think of a four-dimensional shape passing through our three-dimensional space, leaving distortions in its wake. Another idea points to quantum vacuum energy, a seething ocean of particles flickering in and out of existence, possibly manifesting as fleeting lights or gravitational ripples. And then there's the wild card, exotic matter with negative energy density, a substance that could warp spacetime so severely it creates natural cloaking devices, hiding entire regions of the cosmos from view. But the most tantalizing possibility, these anomalies might be signatures of civilizations far beyond our own. If a society mastered energy harvesting on a galactic scale, building Dyson spheres or black hole-powered megastructures, their engineering could leave traces in the light spectrum, subtle irregularities that scream artificial to anyone who knows how to look. The truth is, we're only beginning to develop the tools to probe these mysteries. Next-generation telescopes like the James Webb Space Telescope and the upcoming Nancy Grace Roman Observatory aren't just sharper eyes, they're keys to unlocking the universe's best-kept secrets. Because if history has taught us anything, it's that every time we invent a new way to see, the cosmos reveals a layer of reality we never dreamed existed. And this time, what we find might rewrite not just science textbooks but our very understanding of what's possible. Think of the emptiest space you can imagine, a vast, airless void between galaxies, where even atoms are few and far between. Now here's the twist, that nothingness is a lie. According to quantum mechanics, so-called empty space is anything but. It's a seething, bubbling ocean of energy, where particles and antiparticles flicker into existence for mere fractions of a second before annihilating each other in a cosmic dance of creation and destruction. This is the quantum vacuum, and it's anything but empty. Picture a pot of water on the verge of boiling. At first glance, the surface looks calm, but peer closer, and you'll see tiny bubbles forming and vanishing in an endless cycle. That's exactly how space behaves at the smallest scales. These quantum fluctuations, driven by zero-point energy, the lowest possible energy state of a system, mean that even in a perfect vacuum, particles are constantly borrowing energy from the universe to exist briefly before vanishing again. It's as if the cosmos has a hidden undercurrent, a churning beneath the stillness we perceive. Now, here's where it gets wild. These fleeting particles aren't just theoretical quirks, they have real, measurable effects. The Casimir effect, for instance, proves this. Place two uncharged metal plates incredibly close together in a vacuum, and they're mysteriously pushed toward each other. Why? Because the quantum froth outside the plates exerts more pressure than the limited fluctuations between them, creating an imbalance. It's like trying to hold two floating corks in a choppy sea. The waves outside will inevitably slam them together. But what if this quantum chaos isn't just a microscopic curiosity? What if it's sculpting the universe on a grand scale? Some theories suggest zero-point energy could be the engine behind dark energy, the mysterious force accelerating the expansion of the cosmos. Others propose that virtual particles might briefly warp spacetime itself, bending light in ways that mimic gravitational lenses, or even creating fleeting shadows where light appears to vanish. Imagine walking through a forest where patches of darkness aren't caused by trees, but by the air itself twisting to swallow the light. Could quantum fluctuations be the ultimate cosmic illusionists, tricking us into seeing emptiness where there's only furious activity? The implications are staggering. If the vacuum of space is this alive, what else have we misunderstood? Could entire regions of the sky appear dark not because they're empty, but because their light is being scrambled by quantum chaos? It's a humbling thought. The universe's greatest magic trick might not be hiding objects in the darkness, but convincing us the darkness itself is simple. And if we're only just beginning to grasp the depth of that deception, what other illusions await our discovery? Somewhere in the depths of space, an invisible hand is tugging at our galaxy and everything around us. Meet the Great Attractor, a gravitational anomaly so powerful it's dragging hundreds of thousands of galaxies toward it at speeds exceeding 2 million kilometers per hour. The problem, we can't see it, lurking in a region called the zone of avoidance. This cosmic puppeteer hides behind the thick dust and stars of the Milky Way's disk, where our telescopes struggle to peer through. It's like trying to study a mountain through a blizzard. You know it's there, but the details are blurred beyond recognition. For decades, this mystery has tormented astronomers. The first clues emerged in the 1970s when scientists noticed galaxies in our local supercluster weren't just drifting randomly. They were all streaming toward the same patch of sky near the constellations Centaurus and Hydra. The sheer scale of this motion defied explanation. Whatever lay in that direction had the mass of tens of thousands of Milky Ways, yet optical telescopes saw nothing but a starry void. Even X-ray surveys, which can pierce some dust, revealed only faint hints of massive galaxy clusters nowhere near enough to account for the pull. So what's really out there? One theory suggests the Great Attractor isn't a single object, but a dense knot in the cosmic web, a place where filaments of dark matter intersect, creating a gravitational hotspot. Another idea posits that it's just the tip of something far larger, the Laniakea supercluster, a sprawling network of galaxies spanning 500 million light-years, with the Great Attractor as its beating heart. But the most mind-bending possibility, that we're being pulled by something even more distant, a structure so colossal it warps the fabric of spacetime itself, bending light and gravity like a cosmic funhouse mirror. Now, new tools are finally cracking the veil. Radio telescopes like South Africa's Mercator array cut through the dust with wavelengths invisible to optical instruments, revealing hidden galaxies dancing toward the attractor. The upcoming square-kilometer array, with its unprecedented sensitivity, promises to map this shadowy realm in high definition. Meanwhile, infrared observatories like the James Webb Space Telescope peer past the Milky Way's glare, hunting for the faint heat signatures of stars and gas caught in the attractor's grip. The implications are staggering. If we solve this puzzle, we might unlock secrets about dark matter's distribution or uncover previously unknown megastructures shaping the universe. But here's the haunting part. Every time we think we've peeled back one layer of the cosmic onion, another lies beneath. The Great Attractor could be just the first clue in a chain leading to something even stranger, a reminder that the universe's greatest mysteries aren't always in the light we see, but in the gravitational whispers of what we don't. And that's the thrill of astronomy. The deeper we look, the more we realize how much is still hiding in plain sight. Hubble's iconic deep field image seemed to capture the very essence of cosmic emptiness, a tiny, dark patch of sky no bigger than a grain of sand held at arm's length. At first glance, it appeared almost barren, a void where the universe had simply given up. Then the telescope's long exposure began to reveal the impossible. Thousands of galaxies, swirling in colors and shapes, crammed into that pinprick of darkness. It was a revelation, proof that what looked like nothing was actually everything. But here's the catch: even that staggering image was just the surface. Because Hubble, for all its power, could only see the light our eyes perceive. Beyond that narrow band of visibility, an entire hidden universe was waiting. Enter infrared astronomy, where visible light gets swallowed by cosmic dust. Infrared slips right through, revealing the cold, dark actors in the cosmic play. Take brown dwarfs, failed stars too dim to ignite nuclear fusion, lurking like ghosts in the interstellar night. To Hubble, they're invisible, but point an infrared telescope like the James Webb Space Telescope at the same patch of sky, and suddenly these cosmic phantoms glow with the faint heat of their birth. The same goes for stellar nurseries shrouded in dust, where infant stars are cocooned so thickly that not a single photon of visible light escapes. In Hubble's gaze, these regions are just dark smudges. Switch to infrared, and the smudges explode into intricate tapestries of swirling gas and newborn suns. The difference is staggering. Compare Hubble's visible light image of the Carina Nebula, a misty landscape of stars, with JWST infrared version, where vast, hidden structures emerge like invisible ink under a blacklight. Pillars of dust that seemed solid in visible light dissolve into delicate filaments, backlit by the warmth of stars we never knew were there. Even the so-called empty fields between galaxies, once dismissed as cosmic deserts, teem with rogue planets, cold debris, and the faint infrared glow of objects too dim to register in any other wavelength. This isn't just about filling in gaps, it's about rewriting the script. Every time we unlock a new slice of the electromagnetic spectrum, the universe reshuffles itself. The Hubble Deep Field taught us that emptiness is an illusion. Now, JWST and its infrared brethren are proving that even the fullness we thought we understood was just the prologue. The coldest, darkest corners of space aren't dead zones. They're stages for dramas we're only beginning to witness. And if history is any guide, the next technological leap won't just add to the picture. It'll tear it up and start anew, so the next time you hear about a void in space, remember, we've been wrong before. The universe doesn't do emptiness. It just waits for us to catch up. Every second, trillions of ghostly particles pass straight through your body, and you'd never know it. These are neutrinos, the universe's most elusive messengers, born in the hearts of stars, the fury of supernova, and the violent edges of black holes. Unlike light, which can be blocked by dust or bent by gravity, neutrinos barely interact with matter at all. They slice through planets like they're not even there, carrying secrets from the cosmos' darkest corners. Imagine a whisper so faint it can cross a mountain without fading. That's the power of a neutrino. Detecting these phantoms takes more than a telescope. It requires engineering marvels like the Ice Cube Observatory, a network of sensors buried deep in Antarctic ice. When a neutrino does very rarely collide with an atom, it creates a faint blue flash called Cherenkov radiation. Ice Cube sensors wait patiently in the frozen darkness, capturing these fleeting sparks like cosmic Morse code, and the messages they've decoded are staggering. In 2017, Ice Cube caught a neutrino from a blazar, a supermassive black hole spearing the universe with jets of energy 3 billion light-years away. For the first time, we'd traced a neutrino back to its apocalyptic birthplace, proving these particles could be cosmic breadcrumbs leading us to the universe's most violent events. But here's the mind-bending question. If our eyes could see neutrinos instead of light, what would the sky look like? The familiar constellations would vanish. In their place, a frenetic web of glowing trails, supernova flashing like camera bulbs, the Milky Way's core pulsing with the heartbeat of its central black hole, and perhaps even the shadowy imprint of dark matter annihilations we can't yet explain. The night sky wouldn't be a serene tapestry. It'd be a storm of invisible energies, a real-time map of the universe's hidden machinery. The next generation of detectors promises even more revelations. Projects like the Pacific Ocean Neutrino Experiment aim to turn entire ocean depths into neutrino telescopes, while Dune, a detector filled with liquid argon, will hunt for neutrinos from dying stars to catch the moment a supernova's shockwave tears through a star. These aren't just upgrades, they're gateways to a new kind of astronomy, one where we don't just observe the universe's light, but listen to its silent, subatomic chatter. And if history is any guide, when we learn to hear that whisper, the cosmos will tell us stories we're not even ready to imagine. Dark matter doesn't just hide in the shadows, it bends them. Imagine a cosmic puppeteer, invisible yet powerful enough to twist the very fabric of space, warping the path of light like a funhouse mirror. This isn't science fiction. It's gravitational lensing, one of the universe's most elegant tricks for revealing the unseen. When light from a distant galaxy travels toward us, dark matter's gravitational grip can stretch and distort it, turning pinpricks of starlight into eerie arcs or even multiple mirage-like copies of the same object. The effect is so precise, astronomers use it like a scale, weighing the invisible by measuring how much it bends the light we can see. But how do we know this isn't just a flaw in our equations? Enter the Bullet Cluster, a cosmic collision that handed us proof on a silver platter. When two galaxy clusters smashed together at millions of kilometers per hour, their visible gas, hot and bright in X-rays, piled up in the center, slowed by friction like two clouds merging. But something else kept racing ahead. The cluster's dark matter, detected only by how it warped the light of galaxies behind it. The result, a ghostly silhouette of mass separate from the visible matter. A smoking gun proving dark matter isn't just a mathematical fix, it's real, it's out there, and it's playing by its own rules. Now here's the twist. If dark matter can bend light, could it also erase it? Some theories suggest certain types of dark matter particles might interact with photons in ways we don't yet understand, absorbing them, scattering them, or even redirecting them into dimensions beyond our perception. Picture a cosmic game of hide and seek where the hider doesn't just crouch behind a tree but steals the light so you can't even see the tree. This could explain some of the sky's most perplexing voids, regions where light doesn't just dim, it vanishes without a trace. Up next, we'll dive into the wildest ideas on why light might disappear, from quantum foam to primordial black holes. But for now, let this sink in. Every time we look at a dark patch of sky, we might not be staring at emptiness. We could be peering into dark matter's workshop, where the universe's hidden architect is busy folding, cutting, and sometimes, just sometimes, erasing the light we thought was untouchable. A black hole isn't just an object, it's a cosmic crime scene, a place where light itself goes missing without a trace. At its edge, the event horizon, gravity becomes a one-way street. Cross it and not even light can escape, stretching every photon into an infinite freefall toward the singularity. The result, a perfect darkness, a shadow so absolute it warps the very concept of emptiness. But here's the twist, even these cosmic vacuums aren't completely black. Thanks to quantum mechanics, black holes emit a faint glow called Hawking radiation, a whisper of particles born from the violent tug of war between gravity and the quantum foam at the horizon's edge. It's the ultimate irony. The universe's darkest objects, hiding infinite density behind their shrouds, are slowly evaporating into the void, radiating away their mass particle by particle over eons. Now compare that to their cosmic counterparts, quasars. These blazing monsters are black holes turned inside out, feasting on stars and gas so voraciously that their accretion disks shine with the brilliance of a trillion suns. A single quasar can outshine entire galaxies, lighting up the early universe like a lighthouse in a storm. Yet here's the kicker, quasars and black holes are two sides of the same coin. One is a black hole starving in the dark, the other is a black hole gorging on light. The difference isn't the hole itself, it's the frenzy of matter spiraling toward oblivion, heating up until it screams across the electromagnetic spectrum. This duality forces a haunting question. Are black holes nature's ultimate sensors? Their event horizons don't just trap light, they erase information, shredding the history of anything that falls in. According to general relativity, whatever crosses that boundary is lost forever, its secrets crushed into the singularity. But quantum physics rebels at this idea, insisting information can't just vanish. The conflict, known as the black hole information paradox, remains one of physics' greatest unsolved puzzles. Some theorists suggest the horizon scrambles information like a cosmic hard drive, encoding it in Hawking radiation. Others propose wilder ideas: wormholes, holographic universes, or even that black holes are gateways to other dimensions. But step back and the pattern is clear. Whether it's the quiet glow of Hawking radiation or the dazzling fury of quasars, black holes are more than just traps for light. They're the universe's way of drawing a curtain over its most violent acts, hiding the chaos of spacetime's breakdown behind a veil we're only beginning to lift. And that raises a deeper mystery. If nature goes to such lengths to conceal what happens inside a black hole, what else is it keeping from us? The answer might not lie in the darkness we see, but in the light we're still learning to decode. In the early 19th century, astronomer Heinrich Olbers asked a question so simple it seemed childish, yet its answer unraveled one of the universe's greatest illusions. If space is infinite, filled with an endless number of stars, why isn't the night sky blazing with their combined light? Every direction you look should eventually land on a star's surface, painting the entire heavens in a solid sheet of brightness. The fact that we see darkness instead, what we now call Olbers' paradox, should have been impossible. For centuries, thinkers offered flawed solutions. Maybe dust blocks the light, or stars are too faint. But dust would heat up and glow itself, and faintness doesn't matter when infinite stars add up. The real answer came with a revolutionary idea. The universe isn't infinitely old. Light travels at a fixed speed, and because the cosmos began with the Big Bang roughly 13.8 billion years ago, light from stars beyond that horizon simply hasn't had time to reach us. The darkness isn't empty space, it's a cosmic curtain hiding everything that's too far for its light to have arrived yet. But here's the twist: what if the solution is incomplete? Modern telescopes have spotted galaxies so distant their light has traveled nearly the entire age of the universe to reach us, their stars flickering in ultraviolet before stretching into infrared. Yet even these ancient beacons can't account for all the missing light. Somewhere between here and the edge of the observable universe, photons are vanishing, not just delayed, but lost. Maybe they're swallowed by expanding space itself, redshifted into oblivion, or perhaps they're absorbed by rogue black holes, interstellar dust we can't detect, or even something more exotic, like quantum foam frothing at spacetime's smallest scales. The paradox's legacy lingers in today's greatest mysteries. Dark energy accelerates the universe's expansion, pushing galaxies beyond our light horizon forever. The cosmic microwave background, that faint echo of the Big Bang, is itself a kind of darkness, radiation so stretched by time it's invisible to our eyes. And then there's the unsettling possibility that some light isn't just hidden but erased. Could pockets of the universe exist where photons decay into unknown particles? Where the laws of physics rewrite themselves just enough to extinguish certain wavelengths? Olbers asked why the sky was dark, assuming the answer lay in the stars. But the truth might be far stranger. The night's black canvas isn't just a lack of light, it's a palimpsest, layered with missing signals, scrambled messages, and cosmic censorship. Every dark patch could be a clue, not to what's absent, but to what's been deliberately veiled. And that changes everything. Because if the universe isn't just hiding its light, but actively disguising it, what else is it keeping just out of sight? Cosmic dust is the universe's greatest illusionist, a silent saboteur of starlight, weaving veils of darkness where none should exist. Picture a dense fog rolling over a mountain range, swallowing peaks whole, leaving only a flat, featureless gray. That's precisely what interstellar dust does on a galactic scale. These microscopic grains, no larger than smoke particles, drift between stars, absorbing and scattering visible light like a celestial smokescreen. The result, vast stretches of the sky that appear barren when in reality they're anything but. Take the Coalsack Nebula, a pitch-black blot near the Southern Cross. For centuries, it was dismissed as a void, a literal hole in the Milky Way. But modern telescopes revealed the truth. This emptiness is a dense cloud of carbon and silicate dust, so thick it blocks the light of 500,000 stars behind it. The same goes for the Great Rift, that serpentine shadow winding through our galaxy's core. What looks like a division is actually a sprawling maze of dust lanes, obscuring the frenetic star-forming regions hidden just beyond. Now scale up the deception. The Milky Way's disk is littered with these dust clouds, but none are more notorious than the zone of avoidance, a region so choked with debris it blocks 20% of the sky from view. Imagine trying to map a city by staring through a blizzard. That's the challenge astronomers face when probing this cosmic blind spot. For decades, it hid entire galaxies, their light smothered before it could reach us. Only with radio and infrared telescopes have we pierced the haze, uncovering colossal structures like the Norma Cluster, a gathering of galaxies lurking just behind the dust, their gravity warping spacetime in ways we're only beginning to measure. But here's the unsettling question. If dust can hide something as massive as a galaxy cluster, what else might be concealed? Some theories suggest superclusters, vast webs of galaxies spanning hundreds of millions of light years, could be knitting together behind the Milky Way's dusty curtain, their gravity subtly tugging at our local universe. Others speculate about rogue black holes drifting unseen, or even exotic matter with properties we've yet to imagine. The dust isn't just a barrier, it's a blindfold, forcing us to acknowledge how much of the cosmos remains beyond our gaze. So the next time you look up at a dark patch in the sky, remember, emptiness is an illusion. The universe isn't hiding its secrets out of spite. It's simply waiting for us to look in the right way. And when we do, the shadows might just reveal wonders we never dared to dream. Some galaxies don't blaze across the cosmos, they haunt it. Ultra-diffuse galaxies, or UDG, are cosmic phantoms, sprawling collections of stars so faint they blur into the background of space like whispers in a storm. Take Dragonfly 44, a UDG in the Coma cluster. Despite stretching as wide as the Milky Way, it emits less than 1% of our galaxy's light. Its stars scattered so thinly you could fly through it for millennia and never spot a single sun. For decades, these ghostly giants slipped through our telescopes unnoticed, their dim glow drowned out by the brilliance of neighboring galaxies. It wasn't until advances in low-light imaging, like the Dragonfly telephoto array, a cluster of modified camera lenses designed to catch ultra-faint light, that we began pulling them from the shadows. What makes these galaxies so eerie isn't just their faintness, it's their defiance of expectations. Many UDGs are nearly as massive as the Milky Way, but their stars are spread so thin they barely cling together. Some lack the dense central bulges typical of spiral galaxies, while others float in isolation, untethered to the cosmic web. Even stranger, a few seem to harbor almost no dark matter, the invisible glue holding most galaxies together, while others are stuffed with it, their gravity betraying a hidden weight. It's as if the universe took the recipe for a galaxy and erased half the ingredients, leaving behind these enigmatic half-formed structures. Now, the real mystery: are UDGs cosmic accidents or clues to a hidden population? One theory suggests they're failed galaxies, star clusters that started forming billions of years ago but ran out of gas, literally. Without enough raw material to ignite dense star formation, they faded into obscurity. Another idea posits they're the remnants of violent collisions, galactic shreds torn apart by gravitational encounters and left to drift, but the most tantalizing possibility: they're relics of an early universe where such diffuse galaxies were common, a time before gravity clumped most matter into bright, dense spirals and ellipticals. If true, today's UDGs could be rare survivors of a vanished galactic era, flickering like embers from a fire long since burned out. These phantoms force us to confront a humbling truth: emptiness is a matter of perspective. A patch of sky deemed void by one telescope might shimmer with unseen galaxies under another's gaze. Just as quantum physics taught us that a vacuum teems with particles, UDGs reveal that the cosmic darkness is crowded with structures too subtle for our eyes. The universe isn't just hiding its secrets in black holes or dust clouds sometimes. They're right in front of us, glowing faintly, waiting for us to adjust our vision. And if these nearly invisible giants have eluded us for so long, what else might be lingering just beyond the edge of perception? Einstein called it his greatest blunder, a mathematical fudge factor scribbled into the margins of history. In 1917, while crafting his theory of general relativity, he introduced the cosmological constant, a repulsive force woven into the fabric of space itself, counteracting gravity to keep the universe static. At the time, astronomers believed the cosmos was unchanging, neither expanding nor contracting. But when Edwin Hubble proved the universe was in fact stretching outward, Einstein famously scrapped the idea, dismissing his own constant as unnecessary. To him, it was an embarrassing mistake, a relic of flawed assumptions. Yet here's the twist: Einstein wasn't wrong. He was just 70 years too early. In the late 1990s, two teams of astronomers made a discovery that shook cosmology to its core. By measuring distant supernovae, they found the universe wasn't just expanding, it was accelerating, as if some invisible force were pushing galaxies apart faster and faster. The culprit, a mysterious repulsive energy eerily reminiscent of Einstein's discarded constant. Overnight, his blunder was reborn as dark energy, the dominant force in the cosmos, making up nearly 70% of the universe's total energy. The very thing he'd crossed out now held the key to understanding everything. But why did Einstein dismiss it so completely? The answer lies in scientific hubris, the dangerous allure of certainty. Convinced the universe was static, he tweaked his equations to fit the prevailing wisdom, then abandoned the tweak when that wisdom crumbled. He never considered the possibility that the constant might describe something real, something beyond the paradigms of his time. It's a cautionary tale. Even geniuses can be blinded by the dogma of their era. This raises a haunting question: what other truths have we tossed aside? History is littered with discarded ideas that later proved prophetic. Continental drift was once mocked as pseudoscience. Quantum entanglement was dismissed as spooky action at a distance until experiments proved it real. Could there be other orphaned concepts, equations scribbled out, theories relegated to footnotes, that hold the seeds of future revolutions? The unsettling truth is, we might already have the pieces of tomorrow's breakthroughs buried in yesterday's mistakes. Now, as we grapple with dark energy's enigma, its origin, its nature, its ultimate fate, we're forced to confront the limits of our own vision. The universe doesn't reveal its secrets on demand. Sometimes the answers are hidden in plain sight, waiting for us to shed our assumptions and look again. Einstein's constant wasn't a blunder. It was a beacon flickering in the darkness of human bias. And if we've learned anything, it's that the cosmos has a habit of resurrecting the ideas we're most eager to bury. What if the darkness we see isn't just an absence of light, but a shadow cast by another universe entirely? This isn't science fiction. According to brain cosmology, our universe might be just one membrane floating in a higher dimensional space, like a sheet of paper drifting in a vast cosmic wind. And just as sheets of paper can brush against each other, our universe could have collided with another, leaving scars in the fabric of reality itself. Take the cold spot in the cosmic microwave background, a bizarre, frigid patch stretching across the sky where temperatures dip far lower than standard models predict. At first, astronomers dismissed it as a fluke, but what if it's a cosmic bruise, a remnant of a collision between our universe and another membrane in the multiverse? In this wild scenario, the energy from that impact would have stretched spacetime like a dent in metal, cooling the radiation in that region and leaving behind an eerie, unexplained void. Brain cosmology suggests these collisions might not be rare. If multiple universes exist in higher dimensions, their gravitational pull could warp our own reality, creating pockets where light bends unnaturally or vanishes altogether. Picture standing in a room with frosted glass walls. You can't see the other rooms, but their shadows flicker at the edges of your vision, those empty patches in the sky. They might be the frosted glass of the cosmos, places where the light of another universe bleeds through, or where our own universe's light is being pulled away. Now here's the haunting question: are these voids windows or walls? If they're shadows from parallel realities, they could be our only glimpse into the multiverse. But if they're distortions caused by unseen dimensions, they might be barriers, cosmic blind spots where the laws of physics as we know them simply don't apply. The cold spot could be either a tantalizing crack in reality's facade or a cosmic keep out sign etched into the sky. Either way, the implications are staggering. If even one of these dark patches holds evidence of another universe, it rewrites our place in the cosmos. We're not just staring at emptiness, we might be peering through a keyhole, catching fragments of realities where time flows backward, gravity repels, or stars burn in colors we can't fathom. The night sky's darkness has always been a riddle, but now it might also be a mirror reflecting not just what we don't see, but what we're not meant to see. And that changes everything. Every star you see at night is a time traveler, an echo of light that began its journey years, centuries, even millennia ago. The North Star's glow, that's 640 years old by the time it reaches your eyes. The Andromeda Galaxy, 2.5 million years in the past. This isn't just a poetic quirk, it's the universe's ultimate sleight of hand, where distance and time twist together to hide reality from us. Because light has a speed limit, what we perceive as the present is actually a mosaic of delayed snapshots, a cosmic lag that means parts of the universe remain invisible not because they're dark, but because their light hasn't had time to arrive. Think of it like standing in a thunderstorm. You see lightning flash, but the thunder takes seconds to reach you, a delay revealing how far away the strike was. Now scale that up. The farthest galaxies we've spotted, like GNZ 11, are so distant their light has taken over 13 billion years to reach us. We're not seeing them as they are now, but as infants in the universe's earliest chapters. Beyond them lies a frontier where light hasn't had time to traverse the expanding cosmos at all. The edge of the observable universe isn't a physical boundary, it's a wall of time, a horizon beyond which the cosmic dawn's glow hasn't yet reached Earth. But here's where it gets stranger. The universe is expanding faster than light can bridge the gaps. Galaxies past a certain point are being carried away by the stretching of space itself, their light doomed to never reach us. Their photons are like runners on a treadmill set to cosmic speed, striving forward but making no progress. This means there are stars, planets, even entire civilizations that could exist right now flourishing, evolving, vanishing, whose light will forever remain beyond our grasp. The night sky's darkness isn't just unlit space. It's a curtain drawn by time, hiding universes within universes we'll never witness. Now, consider the implications. If time censors what we see, could it also be hiding deeper truths? Some theorists suggest that black holes might warp time so severely near their event horizons that light from certain angles loops endlessly, never escaping to outside observers. Other models propose that the early universe's rapid inflation stretched quantum fluctuations into vast, invisible structures, cosmic filaments, or parallel realities, whose light is too redshifted or scattered for our instruments to catch. Even the Big Bang's afterglow, the cosmic microwave background, is fading as expansion stretches its wavelengths into undetectable radio silence. One day, future astronomers might peer up at a sky stripped of all but the closest stars, their evidence of the universe's birth erased by time's relentless march. This raises a haunting possibility. What if the cosmos isn't just hiding light but curating it? Like a librarian selectively shelving books, time may be filtering which truths we're permitted to uncover. The universe's greatest secrets might not lurk in the shadows of space, but in the gaps between ticks of the cosmic clock, places where the past hasn't arrived and the present is forever out of reach. So the next time you gaze at a dark patch of sky, remember, emptiness is an illusion. The light isn't missing, it's just running late. The cosmos hums with a paradox. If the universe is so vast and ancient, why does it feel so silent? The Fermi Paradox has haunted scientists for decades. Where are the alien megastructures, the radio signals, the blazing evidence of civilizations beyond our own? But what if we've been listening for whispers in the wrong language? Imagine an interstellar internet built not on radio waves, but on neutrinos, those ghostly particles that slip through planets like they're not even there. A civilization advanced enough to harness them could send flawless, encrypted messages across galaxies, untroubled by dust, distance, or the interference that plagues our primitive radio telescopes. Their conversations might be happening all around us, a cosmic chatter as undetectable to our instruments as a breeze through a stone wall. This isn't just speculation. In 2021, scientists at Fermilab beamed a neutrino message through 700 meters of rock, a proof of concept for communication that could span light years without degradation. Now picture a civilization millennia ahead of us, their technology so refined they've abandoned electromagnetic radiation entirely, opting instead for particle-based networks we're only beginning to fathom. Their cities might pulse with neutrino lasers, their art encoded in the oscillations of particles we can barely catch. To them, our frantic radio broadcasts could seem as quaint as smoke signals. But there's a darker possibility, the cloaking hypothesis. What if advanced civilizations aren't just silent but actively hiding? The universe's history is written in light. Supernova flash, quasars blaze, and even our own TV signals leak into space like a beacon. Yet in a cosmos where predators might lurk, visibility is a liability. A wise civilization could cloak its presence, dismantling megastructures to blend into the cosmic background, or bending light around their worlds like interstellar invisibility cloaks. The Great Silence wouldn't be an absence of life, but a universe playing dead, a galactic game of hide and seek where the stakes are survival. Now look up at the night sky's dark patches with fresh eyes. That emptiness might not be a void, but a velvet curtain drawn across a stage teeming with actors. The stars we see could be the universe's amateurs, the ones still shouting into the dark, while the professionals linger in the shadows, communicating in codes we can't crack, their presence etched not in light, but in the quiet tug of gravity or the fleeting shadow of a cloaked world passing between stars. The Fermi Paradox twists into something new. The sky isn't empty. It's a crowded theater where everyone else has mastered the art of silence. Quantum entanglement is the universe's ultimate magic trick, a phenomenon so bizarre even Einstein called it spooky action at a distance. Imagine two particles born from the same event, linked in such a way that changing the state of one instantly alters the other, no matter how far apart they are. Distance becomes meaningless. A particle on Earth could whisper to its entangled partner near a distant star, and the message would arrive faster than light itself. This isn't science fiction. Experiments have proven it repeatedly, with particles separated by hundreds of kilometers still responding to each other as if they were one. Now, here's the tantalizing question. Could this quantum weirdness be hiding something in plain sight? If entangled photons, particles of light, can be manipulated across vast distances, might they also be used to encode or even erase light in ways we don't yet understand? Picture a cosmic encryption system where certain wavelengths of light are locked by their entangled counterparts, rendering them invisible to our instruments. The voids we see in the sky wouldn't be empty. They'd be scrambled, their light tangled in a quantum dance we're only beginning to decode. Scientists are already pushing the limits of entanglement. Projects like the proposed Space Entanglement Experiment aim to send pairs of entangled photons between satellites and ground stations, testing whether this spooky connection can survive the harsh environment of space. If successful, it could prove that entanglement isn't just a lab curiosity. It's a fundamental feature of the universe, operating on scales we've barely dared to imagine. And if photons can stay entangled across cosmic distances, what's stopping nature from doing this on its own? Consider the implications. A black hole's event horizon, for instance, could be a natural quantum encoder, stretching entangled particles until their light is effectively erased from our view. Or dark matter, which refuses to interact with light, might be cloaked by some form of quantum entanglement we haven't yet discovered. Even the mysterious cold spots in the cosmic microwave background, those eerie voids where temperatures dip unexpectedly, could be signatures of quantum processes playing out on a galactic scale. The most mind-bending possibility, entanglement might not just hide light, it could create the illusion of emptiness. If entangled photons cancel each other out in just the right way, they could produce regions of darkness where light should exist. It's like two waves colliding and silencing each other, leaving behind a perfect stillness. The night sky's voids might not be absences at all, but the aftermath of quantum interference patterns woven into the fabric of space itself. So the next time you gaze at a dark patch of sky, remember, the universe's greatest secrets might not lie in the light we see, but in the invisible threads connecting everything. Quantum entanglement suggests that reality is far more interconnected and far stranger than we ever imagined. And if the cosmos can play tricks with particles across galaxies, what other illusions is it crafting right before our eyes? The universe isn't just dotted with galaxies, it's pockmarked with vast, yawning chasms so enormous they defy comprehension. Picture a cosmic Swiss cheese, where the holes aren't mere gaps but sprawling voids stretching hundreds of millions of light-years across. The Boötes void is one of the most haunting, a spherical abyss so vast you could fit 60 Milky Ways side by side within it and still have room to spare. From Earth's perspective, this region of space appears almost barren, hosting just a handful of galaxies where thousands should exist. It's as if some cosmic hand reached in and scooped out the stars, leaving behind a chilling emptiness that whispers of mysteries we're only beginning to grasp. But here's the twist, these voids aren't truly empty. Even in the deepest reaches of the Boötes void, astronomers have detected faint traces of hydrogen gas, rogue stars flung from galactic collisions, and the subtle gravitational tug of dark matter, the universe's invisible scaffolding. What looks like nothingness is actually a dynamic arena, where exotic particles and quantum fluctuations might be playing out dramas we can't yet perceive. Some theories suggest these voids could be seeded with dark energy highways, regions where the repulsive force accelerating the universe's expansion is concentrated, stretching space-time itself like taffy. Others propose there the aftermath of ancient cosmic battles, where superclusters of galaxies collided and merged, leaving behind these desolate battlegrounds. The eeriest possibility, voids might be the universe's blind spots, not just empty but deliberately obscured. Imagine a fog so dense it doesn't just block light but erases it, scrubbing photons from existence. Certain models of quantum gravity hint that space-time itself could become unstable in these vast, underdense regions, creating pockets where the laws of physics fray at the edges. Light passing through might be stretched into oblivion or even tunnel into higher dimensions, leaving behind a perfect cosmic silence. It's like shouting into a canyon and hearing no echo, not because there's nothing there, but because the canyon is stealing your voice. Now contrast this with the vibrant filaments of the cosmic web, where galaxies cluster like cities along glowing highways of gas and dark matter. The voids are their inverse, not just empty space, but negative space, shaping the universe as much as the matter itself. They're the pauses between the symphony's notes, the silence that gives meaning to the sound. And just as silence can hide secrets, these voids might be concealing forces or phenomena we haven't even named yet. After all, the universe has never been content to simply be. It's always hiding, always revealing, always daring us to look deeper. So when you stare into the void, remember, it's not staring back. It's waiting for us to learn how to see. What if the darkness we see isn't just empty space, but a living, breathing entity, radiating light in wavelengths we've never thought to look for? Picture this, vast stretches of the cosmos pulsing with bioluminescence, not from stars or gas, but from something far stranger, cosmic-scale life. It sounds like science fiction, but the universe has already shown us how creative it can be. On Earth, creatures like jellyfish and fireflies use chemical reactions to produce light without heat, a phenomenon we call bioluminescence. Now, stretch that idea across light years. Imagine nebulas not just as clouds of gas, but as colossal organisms, their tendrils flickering with cold, living light in ultraviolet or infrared wavelengths invisible to our eyes but teeming with energy. This isn't just wild speculation. Some fringe theories suggest that if life can emerge in the scalding vents of ocean floors or the frozen cracks of Antarctic ice, why not in the turbulent nurseries of space? The ingredients are there. Complex organic molecules float freely in nebulas, and cosmic rays provide energy where sunlight falters. Even water, a key ingredient for life as we know it, exists in abundance, locked in comets and interstellar ice. Perhaps the most tantalizing idea comes from astronomers like Fred Hoyle and Chandra Wickramasinghe, who proposed that nebulas could harbor microbial life or even something more complex. If true, these cosmic organisms might communicate or metabolize using bioluminescent signals, their heartbeats pulsing in rhythms we've never tuned our telescopes to catch. Think of it like this: deep in our oceans, entire ecosystems thrive around hydrothermal vents, their inhabitants glowing in the eternal dark. To a surface dweller, those depths seem barren. But lower a camera and the abyss comes alive with light. Could the same be true of the cosmos? Our instruments are calibrated for the blaze of stars, not the soft glow of potential life. Even the James Webb Space Telescope, with its infrared eyes, might overlook subtle bioluminescence if it's drowned out by the background hum of the universe. The dark patches we dismiss could be vibrating with activity, their light encoded in ways we don't yet recognize. Now, take it a step further. What if this hypothetical life isn't just passive but sentient? The idea of sentient nebulas or galaxy-spanning organisms is a staple of sci-fi, but some theorists argue it's not entirely implausible. A sufficiently advanced civilization, or even a naturally evolved mega-organism, might harness bioluminescence to communicate, camouflage, or even manipulate its environment. Picture a nebula that plays dead, dimming its light to avoid detection, or one that flares intentionally to lure in energy-rich comets like a cosmic anglerfish. It's a dizzying thought. The greatest act of cosmic hide-and-seek might not be dust blocking our view, but life itself choosing to stay silent. Of course, this is all speculation, the kind that makes physicists raise an eyebrow. But that's the beauty of the unknown. Every revolutionary idea, from black holes to the multiverse, started as a what-if on the fringes of science. The universe has surprised us before, revealing wonders where we once saw only voids. So the next time you gaze at a dark patch of sky, consider this: emptiness might be a matter of perception. The light we're missing isn't just hidden, it could be alive, whispering in a language we're only beginning to imagine. And if that's true, the greatest discovery in history might not be finding life among the stars, but realizing it's been shining back at us all along. What if the night sky's darkness isn't just an accident but a design flaw? That's the unsettling premise of the simulation argument, a hypothesis suggesting our universe might be an artificial construct, and the voids we see are clues to its digital scaffolding. Philosopher Nick Bostrom's famous thought experiment lays it out. If advanced civilizations could run ancestor simulations, hyper-realistic recreations of their past, the statistical likelihood we're living in the real base reality shrinks to near zero. And if we are in a simulation, the sky's emptiness starts to make eerie sense. Rendering every distant star in perfect detail would be a computational nightmare, like a video game straining to draw mountains on the horizon. Why waste processing power on galaxies no player will ever visit? The simulation might cut corners, leaving voids as cosmic loading screens, regions where the code simply skips the details to save resources. Think of it like an open-world game where distant landscapes are blurred or replaced with low-res textures until you get closer. Now imagine that on a universal scale. Those dark patches between stars, they might not be empty, just unrendered, their light deliberately left uncomputed because no one's looking. Even stranger, glitches could lurk in these digital blind spots. Just as a game might flicker or distort when pushed to its limits, our simulated cosmos might reveal its artificiality through anomalies, patches of sky where light behaves unnaturally, or where the rules of physics stutter. Astronomers have already spotted a few oddities: galaxies that rotate too uniformly, particles that defy energy conservation, or cosmic voids that seem too perfect in their emptiness. Could these be bugs in the code? But here's the twist: if the simulation hides distant stars to conserve power, why let us see any of them at all? One answer lies in the concept of minimum viable reality. A convincing simulation doesn't need to render every atom, just enough to keep its inhabitants from suspecting. The stars we do see might be procedural placeholders, like background art in a theater, while the true depth of the universe remains locked behind a digital curtain. And if that's true, the greatest cosmic mysteries, dark matter, quantum entanglement, even the nature of consciousness, might not be puzzles to solve, but intentional firewalls, keeping us from poking at the simulation's source code. So the next time you gaze at a dark sky, consider this: the universe might not be hiding its light, it might be buffering, and if we ever find a glitch, a patch of space where the stars flicker, or a law of physics that resets like a frozen screen, it won't just change astronomy. It'll change everything, because in a simulated universe, the greatest discovery wouldn't be alien life or new physics. It'd be the realization that we're not the players. We're the program. Gravitational waves are the universe's silent symphony, ripples in space-time so subtle, they bend the fabric of reality itself by less than the width of an atom. Yet in that infinitesimal shiver, hidden within the static of cosmic noise, lies a revelation. We've unlocked a way to hear the cosmos, bypassing light entirely. When the Laser Interferometer Gravitational Wave Observatory, or LIGO, captured its first wave in 2015, it wasn't just a breakthrough, it was a paradigm shift. Two black holes, each dozens of times the mass of our Sun, spiraled into each other over 1 billion years ago, merging in a collision so violent it sent tremors across the universe. No light escaped that event, no star flared, no nebula glowed, but LIGO twin detectors, separated by thousands of miles, caught the echo of that invisible cataclysm as it stretched and squeezed spacetime like a passing breeze distorting a spider's web. This is astronomy without light, a realm where darkness isn't an obstacle but a canvas. Gravitational waves don't care about dust clouds or redshift. They slice through planets, stars, even entire galaxies unimpeded, carrying whispers of events no telescope could ever witness, neutron stars colliding. Heard it, black holes dancing in the void before their final embrace, caught that too. Even the faintest murmurs from the universe's earliest moments, when spacetime itself was a roiling sea of quantum foam, might one day be decoded from these waves. It's as if we've been staring at a silent film for centuries, and suddenly, someone turned on the sound. Now, imagine a future where gravitational wave detectors are as ubiquitous as optical telescopes. Picture a gravity map of the sky, not with stars and galaxies, but with vibrating black holes, quaking neutron stars, and perhaps even cracks in spacetime from cosmic strings, theoretical defects left over from the Big Bang. The night sky's familiar constellations would fade into irrelevance, replaced by a dynamic, ever-changing sonogram of the invisible universe, that patch of darkness where Hubble saw nothing. It might thrum with the gravitational echoes of a supermassive black hole's last meal. The Orion Nebula's glittering gas clouds could pale next to the gravitational signature of a neutron star spinning at the brink of collapse, its surface cracking under unimaginable pressures. But here's the haunting question. If gravitational waves become our primary lens, will the cosmos still seem empty? Or will we uncover a hidden density of events so frequent, so violent, that the universe's voids were never voids at all? Already, LIGO data suggests binary black hole mergers might be startlingly common, occurring every few minutes somewhere in the universe. The silence we perceived wasn't absence, it was a limitation of our senses. Like bats navigating by echolocation, we're only beginning to grasp how noisy the darkness truly is. And the most profound implication, gravitational waves might be our only window into the universe's darkest secrets. Black holes, those perfect traps for light, are virtuosos of gravity's symphony. Dark matter, which shuns photons, could reveal its presence through subtle distortions in spacetime's ripples. Even the birth cries of the cosmos, long since redshifted into oblivion, might linger as a gravitational hum beneath everything. The universe's greatest show isn't playing in the light. It's happening in the vibrations we're just learning to feel. So the next time you look up at a seemingly empty sky, remember, the stars are just the overture. The real performance is in the silence between them. When Hubble first turned its gaze toward a seemingly empty patch of sky in 1995, astronomers braced for disappointment. Instead, the deep field image shattered expectations, revealing thousands of galaxies crammed into a sliver of darkness no wider than a grain of sand. That single observation rewrote our understanding of cosmic emptiness overnight. Now, with the James Webb Space Telescope's infrared eyes piercing deeper into the void, we're on the verge of another revolution, one that could expose wonders Hubble couldn't even hint at. Webb's greatest weapon is its ability to see through cosmic dust, the universe's ultimate smoke screen. Where Hubble's visible light vision blurred into obscurity, Webb's infrared sensors cut through the haze like thermal goggles in a fog. Take the pillars of creation, those iconic towers of gas in the Eagle Nebula. Hubble's version was majestic, but Webb's infrared portrait revealed hidden stars flickering within the dust, their infant light previously smothered. Now apply that power to the sky's empty regions. Those dark patches could be stellar nurseries so thick with dust that not a single photon of visible light escapes. Webb might peel back the curtain, exposing newborn stars mid-formation, their heat signatures betraying their presence long before they ignite into visible brilliance. But the real prize, primordial stars, mythic giants from the universe's infancy, composed purely of hydrogen and helium, untouched by the heavier elements forged in later supernova. Theory predicts these population 3 stars burned hot and fast, vanishing billions of years ago. Yet their light, stretched by cosmic expansion into Webb's infrared sweet spot, might still linger at the edge of detection. Finding even one would be like uncovering a fossil from the cosmic dark ages, a relic from when the first starlight pierced the universe's primordial gloom. And then there's the unknown, the anomalies Webb wasn't even built to find. Hubble stumbled upon accelerating cosmic expansion by accident while studying supernova. Webb could reveal equally shocking surprises: rogue planets drifting between stars, galaxies so ancient they defy stellar evolution models, or even, whisper it, structures that hint at intelligence beyond Earth. Every time we've built a better telescope, the cosmos has responded by revealing layers we never imagined. Webb isn't just another instrument, it's a key to doors we didn't know existed. So when you hear about a new void in the data, remember Hubble taught us that emptiness is an illusion. Webb's job is to show us what's been hiding in plain sight all along. The night sky's darkest corners aren't in points, they're starting lines, and the race to decode them has only just begun. One of the most thrilling revolutions in modern astronomy isn't happening in high-tech labs or atop remote mountaintops. It's unfolding in living rooms and backyards around the world. Citizen science has turned the search for cosmic mysteries into a global collaboration, where anyone with curiosity and an internet connection can help uncover the sky's best-kept secrets. Take the Galaxy Zoo project, which invited volunteers to classify millions of galaxies from telescope images. What started as a way to crowdsource data analysis led to something extraordinary. Ordinary people began spotting anomalies professionals had overlooked. One volunteer, Dutch schoolteacher Hanny van Arkel, discovered a strange green blob in a galaxy survey, a celestial oddity now known as Hanny's Voorwerp, a cosmic ghost lit by the radiation of a long-dead quasar. Her backyard observation sparked a scientific paper and rewrote our understanding of galactic evolution. Then there's the Zooniverse platform, where amateur sleuths sift through data from sky surveys like Pan-STARRS, hunting for everything from gravitational lenses to rogue planets. In 2017, a retired electrical engineer named Paul Rose noticed a star that dimmed in an unusual pattern, a signature later confirmed to be a rare, self-lensing binary system where one star passes in front of another, magnifying its light like a natural telescope. These discoveries aren't flukes, they're proof that the human eye, trained by intuition and passion, can spot patterns algorithms miss. After all, machines excel at processing data, but they don't get goosebumps when something looks off. The beauty of this movement, you don't need a PhD or $1 million telescope to participate. Apps like Backyard Worlds let users scan infrared data from NASA's WISE telescope, leading to the discovery of dozens of previously unknown brown dwarfs, failed stars lurking in our cosmic neighborhood. Some volunteers have even co-authored scientific papers, their names etched alongside career astronomers. And for those with modest telescopes, projects like the American Association of Variable Star Observers also welcome contributions tracking the flickers of distant suns, data that helps professionals unravel stellar life cycles. What makes these efforts so powerful is their democratization of discovery. The night sky's illusions, those dark patches and fleeting anomalies, aren't just puzzles for elites in observatories. They're riddles waiting for anyone willing to look closely. Every time an amateur points a lens at the heavens or clicks through an online sky survey, they're joining a centuries-old tradition of cosmic exploration. Only now the tools are better, the data is vast, and the potential for revelation is limitless. The universe's greatest deceptions might not be uncovered by a lone genius in a lab, but by a teacher in Amsterdam, a retiree in Ohio, or maybe, just maybe, by you. For millennia, indigenous cultures have woven stories about the sky, not as a void to be conquered, but as a sacred tapestry holding knowledge meant only for the gods. The Navajo speak of celestial beings who forbade humans from gazing too deeply into certain stars, while Aboriginal Australians describe songlines in the heavens that must be approached with reverence, not instruments. These aren't just myths, they're cautionary tales about the dangers of unchecked curiosity. Now, as our telescopes pierce deeper into cosmic shadows, we're forced to confront an uncomfortable question. Are some truths better left veiled? Consider the fate of the Arecibo message, a deliberate radio signal beamed toward a star cluster in 1974, carrying humanity's location, DNA structure, and even a crude self-portrait. At the time, it was hailed as a triumph of outreach, but critics warned it was reckless, a cosmic version of shouting into a jungle without knowing what might shout back. The debate echoes an older dilemma. When explorers first landed on distant shores, their curiosity often brought unintended devastation. Could the same happen if we blindly illuminate corners of the cosmos we don't yet understand? Some astrophysicists argue that advanced civilizations might perceive our prying instruments like the James Webb Space Telescope's infrared gaze as intrusive, even threatening. After all, if you discovered a neighbor peering through your windows with thermal cameras, you wouldn't call it science, you'd call it trespassing. Yet the ethical lines blur when we confront discoveries that challenge our very existence. Take dark energy. If experiments proved it was actively erasing the universe's light, would publishing that truth trigger global despair? Or imagine uncovering evidence that our universe is a simulation, a revelation that could unravel religions, economies, and societal structures overnight. Historians point to the Copernican revolution, which shattered Earth's cosmic centrality and ignited centuries of upheaval. Today's equivalents might lurk in the data streams of gravitational wave detectors or the pixelated depths of deep field images. The dilemma isn't just about finding these truths, it's about whether we're prepared to live with them. Indigenous wisdom offers a counterbalance to this relentless pursuit. Maori star navigators, for instance, teach that certain celestial knowledge is tapu, sacred and restricted. To them, the sky isn't a problem to solve but a relationship to honor. Modern astronomy could learn from this humility. Instead of treating every cosmic shadow as a puzzle to dismantle, What if we approach them with the caution of archaeologists handling fragile artifacts? The Vatican's own observatory, perched atop Castel Gandolfo, embodies this tension. Its astronomers peer through cutting-edge telescopes while surrounded by frescoes of angels, a reminder that some mysteries might belong to realms beyond equations. The most profound ethical test may lie ahead. If we one day decode a signal from an alien civilization, would sharing it unite humanity or fracture it? SETI post-detection protocols are vague, leaving disclosure decisions to politicians rather than scientists. And what if we stumble upon light that wasn't meant for us, a wavelength engineered to remain hidden, or a structure so unnatural it implies a creator? The universe has already shown it censors truths. Black holes shred information, dark matter hides in plain sight. Perhaps the greatest discovery wouldn't be piercing the darkness, but recognizing when to look away. After all, true wisdom isn't just knowing what we can uncover, but what we shouldn't. The Vera Rubin Observatory perches on a Chilean mountaintop like a sentinel waiting for dawn, but what it's poised to reveal isn't sunlight. When this behemoth opens its eyes in late 2024, its 2-gigapixel camera will capture the entire visible southern sky every few nights, creating a time-lapse movie of the cosmos on a scale never before attempted. Nicknamed the dark matter detective, Rubin's real power lies in its ability to trace the invisible. By mapping how distant galaxies warp light around them, a phenomenon called weak gravitational lensing, it'll chart dark matter's hidden scaffolding in unprecedented detail. Those patches of sky that once seemed barren, they'll thrum with the gravitational fingerprints of matter we can't see, turning cosmic voids into intricate three-dimensional maps of the unseen. Then there's LISA, the Laser Interferometer Space Antenna, a trio of spacecraft set to launch in the 2030s, trailing Earth in orbit like a celestial harp. While LIGO listens for gravitational waves from colliding black holes, LISA million-kilometer long arms will detect lower-frequency ripples, the slow dance of supermassive black holes merging at the hearts of galaxies, or even tremors from the universe's first microseconds. Imagine hearing the aftershocks of the Big Bang itself, a soundtrack to creation that's been playing silently for 13.8 billion years. LISA might also spot cosmic strings, hypothetical defects in spacetime left over from the universe's birth. If they exist, these filaments would slice through the void like invisible razor wires, warping light and spacetime as they vibrate. But the most tantalizing targets are Earth-like exoplanets. The Habitable Worlds Observatory, a proposed NASA mission for the 2040s, aims to block out parent stars' glare to directly image pale blue dots orbiting distant suns. Current telescopes can barely spot Jupiter-sized planets. This one could analyze the atmospheres of rocky worlds for oxygen, methane, or even technosignatures, chemical traces of industrial civilization. Suddenly, the empty space between stars becomes a highway of potential habitats, each twinkling with the promise of life. These instruments share a common thread. They're designed to interrogate the darkness. Rubin exposes dark matter's shadow play, LISA eavesdrops on spacetime's whispers, and next-gen observatories hunt for planets hiding in their star's brilliance. The sky's emptiness has always been a trick of perception, a limitation of our tools rather than the universe's design. With each technological leap, we peel back another layer of the cosmic illusion, revealing a reality far stranger and more crowded than we ever imagined. The void isn't empty, it's just been waiting for us to learn how to look. I remember the first time I truly saw the night sky, not just glanced at it, but really looked. It was years ago, camping in the high desert where the air was thin and the darkness absolute. No city glow, no headlights, just an endless black canvas speckled with stars. At first, it felt peaceful, almost comforting. Then, as my eyes adjusted, the sheer scale of it hit me. That vast emptiness between the stars wasn't passive or dead. It was alive with possibility, a silent reminder of how little we truly see. I pointed my flashlight upward, and the beam disappeared into the void as if the sky had swallowed it whole. That moment stuck with me, not because of the stars, but because of the darkness that held them. There's something humbling about confronting that kind of emptiness. It's easy to feel small under a sky so expansive, but there's another layer to it. That darkness isn't just absence. It's a challenge, an invitation to wonder what's lurking just beyond our perception. Think of the ancient navigators who sailed by the stars, trusting pinpricks of light to guide them across oceans of unknown. They didn't see the emptiness as a void. It was a map, a story waiting to be read. Today, we're not so different. Every time a telescope reveals a galaxy hidden behind dust or a gravitational wave detector catches a ripple from a collision a billion years ago, we're adding another stitch to that map. And yet, for all our tools, the universe still holds its cards close. Dark matter tugs at galaxies without showing itself. Black holes erase their own histories. Even the light we've learned to capture, infrared, X-ray, radio, is just a fraction of what's out there. That's the beautiful paradox of astronomy. The more we discover, the more we realize how much we're missing. It's not a failure, it's the engine of curiosity. Every unanswered question, every patch of sky that resists explanation, is a reminder that wonder and science aren't opposites. They're partners. The moment we stop being astonished by the darkness is the moment we stop looking deeper. So the next time you find yourself under a clear night sky, try this. Don't just look at the stars. Look at the spaces between them. That's where the real magic hides, not in what we know, but in what we've yet to imagine. Because the universe isn't just a collection of lights. It's a conversation, and the silence between the words might be the most important part. From the ancient myths that painted stories in the stars to the cutting-edge telescopes revealing quantum whispers in the void, one truth remains constant. The sky's so-called emptiness is anything but. Those dark patches we once dismissed as nothing are cosmic illusions, hiding light we weren't meant to see, whether cloaked by dust, stretched by time, or erased by the universe's own censorship. Every breakthrough, from Hubble's deep field revelations to LIGO gravitational murmurs, has peeled back another layer of the illusion, proving that darkness is not an absence. It's a challenge, a riddle written in the fabric of space-time itself, daring us to look deeper. Think of it like standing in a hall of mirrors where every reflection reveals another doorway. The Great Attractor tugs at galaxies we can't see. Dark matter weaves invisible scaffolds between the stars. Even the quantum foam beneath our feet bubbles with particles flickering in and out of existence. For every question we answer why the night sky is dark, what lurks in cosmic voids, a dozen more take its place. The universe doesn't surrender its secrets easily. It invites us to keep searching, to keep questioning, even when the answers rewrite everything we thought we knew. Carl Sagan's pale blue dot reminds us of our place in this grand tapestry, a speck suspended in a sunbeam, dwarfed by the vastness around us. Yet that very vastness is what makes our curiosity extraordinary. We are the universe's way of understanding itself, turning its hidden light into stories, equations, and meaning. The darkness isn't a void to fear. It's a canvas, and every telescope, every algorithm, every pair of eyes gazing upward adds another stroke to the portrait. So the next time you stand beneath the night sky, remember, the stars are just the prologue. The real story lies in the shadows between them, in the questions we haven't yet thought to ask. Keep looking up, keep wondering, because the universe isn't finished surprising us, and the greatest discoveries are still waiting in the light we've yet to see.